Hello, and welcome to Calculus 1. So we're going to start today by briefly reviewing the syllabus, and then we'll start the new material. Actually, we're going to start with review of pre-calc, and then we'll start the new material when that's finished. So let's start by looking at the syllabus. Um, this is available, by the way, in Brightspace. In fact, I'll tell you what, why don't we go over to Brightspace for a second and take a look at it. So we would have under Brightspace Home, you probably only have one class listed there. And so it's Calculus 1. And so the way I've set it up is that you've got several of these different, as they're called, modules on Brightspace. And the first one is this prepping for purchase, which contains information about the college and things you should know in order to take an online class. Let's just take a quick look at it. Oh, all kinds of useful things like student responsibility, financial details, due dates, all that type of thing. Those are all listed here in case you have any questions. And then we also have, of course, the syllabus. Let me just go open that up for you. It's found here under the syllabus. I already have a copy of it open right here, so let me switch over here. So let's go through the details really quickly. The title of the course is Math 1500 Calculus 1. We're at Purchase College in Purchase, New York, which, if you're not familiar with this area of the country, it's in the suburbs of New York City. And here's my information, Alan Anderson, PhD. The classroom is online because, of course, this is an online course. And in fact, it's not even just online, it's asynchronous, which means that we never actually meet at the same time. So the advantage of this approach is that everybody's schedule is probably different. So you can access the materials when it's convenient for you. We don't have to meet at any particular time. And all the lectures are being recorded and they'll be posted on both Brightspace and my YouTube account. Now, the reason why I'm doing that is because it's been my experience that systems like Brightspace, they don't always have enough storage for videos. Videos apparently take up a lot of space. So what I do as a precaution is I set up, I put the videos on my own YouTube account. And I've been doing this for many years now, certainly since the COVID, when all the classes were online. And you'll see, um, here we go. If you look here, now this little A means that it's my account. The actual name is Dr. ACA. So if you're wondering where to find my information, here it is. So if you look at my channel, you'll see that there's a lot of files here. This is going back several years. So what I am doing here is I'm going to create a playlist just for our class. It isn't there just yet, but I will put it up there and it will have the name of the course and summer 2024. And so you'll see all the videos will be together in one place. And they'll also be on Brightspace as long as there's enough room. Okay. So this way, either way, you'll be able to find what you're looking for. But I noticed that sometimes there will be limits on how long each video can be or how much total space I have. And so just to avoid that, I'm going to put all the videos on both Brightspace and here. Okay. Anyway, office hours TVA, that means that if you want to have office hours, if you want to ask questions or go over something, you can just send me an email and let me know when you're available and we'll work it out together. And that just means that you and I will be on Zoom like we are here, and then we'll just be going over your questions. Now, for simpler questions where you don't need to really get together, you can always send me emails. Here's my phone number if you really need it. This is my purchase email address. If you notice, I sometimes will send out information to you from my personal Gmail account, only because it's easier to send a mass mailing, I guess you would call it, where I can address many people at once. There's something about the purchase account. It doesn't seem to work that way. I'm finding myself forced to type all the email addresses individually, and that's awfully time consuming. So at least with Gmail, I can copy and paste all of your email addresses directly from an Excel spreadsheet. And that's why I tend to use that. The text, yes, of course, there's a textbook. Now, this book, you can buy the hardcover if you want to. If you prefer hardcover books, that's fine. But the learning system that we'll be using, which is called WebAssign, has its own copy of the book, which I'll show you right now. If you go into your Cengage account, which, by the way, I sent out instructions yesterday for how to sign up for your WebAssign account. You have to actually go through the formality of signing up for it. It doesn't happen automatically. You're already enrolled in Brightspace. You already have access to it, but this has to be set up separately. So, oh God, let's see now. Unfortunately, I'm still learning the system myself. So I'm fumbling around here looking for the right buttons to push. Okay. Wow, this is very different than what I'm used to seeing. This is the table of contents for the book, by the way. You can get it in a couple of different ways. You can click this little blue icon over here, or else if you're on the main page, which I can't seem to get back to here for some reason. It's not helping either. I may have to just sign out and start all over again. I don't know what I did wrong. By the way, you'll notice as the semester goes along, technology is not my friend. Um, I find it very difficult to use it, and it always somehow manages to find a way to break down at the worst possible moment. So, I think here we are. Okay, so this is the main page. If you click this on, you'll find yourself in your class, it's called, and then here we go. Here's your ebook. Okay, and that brings you here. But then let's see if that works. There we go. Okay, so ebook is here, and that'll bring out the book. And here you're looking at the main index. Now, if you look at the syllabus, you'll see that we're going to cover not all of the first 8 chapters, chapters 1 through 5 and 7 and 8. In other words, it's the first 8 chapters except for number 6. Differential equations is a separate topic. You can take an entire semester of differential equations, and you might if you're a math major, but we're not going to have time to do that here. We've only got 8 weeks to cover the entire contents of Calc 1. So this one, you can read it on your own if you're interested, but we won't have time to do that. What else is here? By the way, I've noticed that so far one person has successfully signed up for WebAssign, which is good because I just sent out the email yesterday, but it also means that the links have been set up correctly, which really was the biggest headache. So going forward, I expect over the next few days, people will be able to sign up for their accounts. And once you have, you'll be able to start working on the assignments. You'll number two things actually. You'll have access to your ebook, and number two, you'll be able to start working on the assignments. Now, I haven't chosen the assignments for week 1 just yet, so there's not going to be anything there just yet. But in the next day or so, I'll choose the questions for the first week, and then they'll become available to you, and you'll be able to work on them in your own time. All right. So what else do we need to know from this syllabus? Besides the book, which we just looked at, the WebAssign, which is where all the assignments will be. Here we have a brief discussion about what we're going to cover this semester. This is a standard Calc 1 course. Every topic that you could possibly do in Calc 1 will be doing. So your schools we'll have no trouble accepting your transfer credits because we're covering everything that we need to do. Let's see. Then there's a list of the topics. You can go through that if you want to. The grading, for this course, a lot of the weight comes down to these web sign problems, 40%. And you'll see why when you start working on them. You'll be getting a lot of practice with them. And they will grade themselves, by the way, as you go along. You'll know right away how you did when you finish your assignments. And not only that, but when you're working on the assignments, you'll often get multiple opportunities to try again if you didn't get them right the first time. It'll give you helpful hints about what you did wrong, if there's anything wrong. It will also give you links to the textbook to help you find the parts of the book where this information is covered if you need to refresh your memory. And also there should be many videos scattered throughout these assignments that will enable you to better understand what you're supposed to do. So it's a very helpful interactive system for learning the material and getting practice with it. So far, I've had good success with these online systems. I find that the grades tend to be very high for the assignments because they're so user-friendly and so helpful. Okay. As opposed to having you write it all down on a piece of paper and handing it in. This way you'll have constant feedback about what you're doing. Now, having said that, let's now go back and revisit Brightspace for a minute. Yeah, here's YouTube. We don't need that anymore. That's where one of the two places where I'll be posting your videos. Now, we can get rid of this. The Brightspace. Yeah, let's see what happened to my Brightspace. All right, I guess it's gone. I'll just go reopen it. Oops. All right, here we go. So anyway, you can see that we have here, besides prepping for purchase and syllabus, we have something called preview of calculus. So what we're going to do here, before we start with the actual new material, we're going to quickly review what you learned in pre-calculus, because I don't know how long it's been since you all had pre-calculus, and I don't know how well you did. What I want to do is make sure we're all on the same page when we start the calculus material. So what you're seeing here is notes that we'll be covering that are meant to be an overview of what you did in pre-calc, so that when we start the new material in chapter 1, which is our introduction to limits, you'll be in pretty good shape. Okay, in other words, your memory will be refreshed. You'll remember all these important concepts that you've learned in the past, and you'll be ready to roll. So anyway, I do want to point out here one interesting thing. If you notice, all of these chapters that I've put here, all these parts there's two of them. You're probably wondering, why are there two? Well, one of them is a PowerPoint presentation, and one of them is a PDF document. What's going on with that? Well, the notes, as you'll see right here, are on PowerPoint. The only problem is these notes contain a lot of equations and graphs too, for that matter. Now, I'm using the special software called MathType for the equations. And MathType is an interesting product. Once upon a time, it was actually included with Microsoft products like Word and PowerPoint. And then somehow they got away from it and they created their own very inferior version, in my opinion. So you now have to pay for MathType if you want to use it. Now, that shouldn't have been a problem, but unfortunately, somewhere along the way, the Macs stopped supporting it. Okay, at one point in time, the MathType was compatible with both Macs and PCs. And then somewhere along the way, Apple decided not to support it anymore. So what that means is that if I send you these slides or post these slides in PowerPoint, and they contain equations or graphs like these you're seeing here. It's very possible that if you open them up on a Mac, you won't be able to see anything, or either that or they'll be mangled, they'll be garbled. You won't be able to see what they're supposed to say. So the advantage of PDF is that no matter what platform you're using, you'll be able to see exactly what I've done. It's like basically a picture of the notes. The drawback to PDF, though, is that it's very difficult to write on the slides directly, like I will be doing throughout this course. So I will be using the PowerPoint versions in the class, but when you open these up, if you're using a Mac, you may want to use the PDF version. Now, there's always issues. I mean, like I said, technology is not my thing. I hope that we won't have any problems, but if you do, you can always let me know. In fact, anytime you have any kind of issues with WebAssign or the questions or the rights or anything, no matter what it is, let me know right away and I'll get it taken care of. Cengage is very, very good about customer support. And so if you're not able to get into WebAssign or if there's something wrong with it, they'll get it fixed very quickly. Okay, you can count on them. They're very good. Okay. So anyway, like I said, this is the preview. And in fact, if you look at your book, you'll see that that's exactly how they have it listed there. Let's go back and reopen the ebook for a second. They called it preparation for calculus. It's the same thing. So what they're doing here is basically reviewing with you a lot of the key concepts that we'll need for Calc 1. Okay, so now I may be covering even a little bit more than they are here just to make sure that we're all set. But once this is done, we're going to go right into chapter 1. And what we're going to do is start with the first key concept in calculus, which is limits. Okay, that's the foundation for what comes afterwards, limits. Okay, and then we'll go on to differentiation and its applications. We'll be looking at integration and its applications. And so by the time we're done, you'll have a very solid background in calculus. Okay. And of course, if you are a math major, you'll have to go on to Calc 2, probably Calc 3. Even if you're not, if you're just studying economics, for example, or some other discipline, you may need to take 1 or 2 semesters of calculus. By the way, this book was intended to cover all the first 3 sections or semesters of calculus, which is pretty normal for calculus books. That's one of the reasons why they're so expensive, because it really is a 3-semester book. We're only going to look at the first semester, but you can feel free to read ahead if you want to. Okay. All right. Now, we're going to start today looking at our preview of calculus. And I do want to point out that pretty much all of this is review. It's just that I don't know how long it's been since you thought about these concepts. If it seems very basic, it is to a certain degree, but don't worry, that will change very quickly. Okay. But there's certain things we don't want to forget. And so we'll start at the beginning. We'll review these very important ideas. And then when we're ready, we can start looking at limits. All right. So we start by reviewing the concept of functions. Of course, functions are at the heart and soul of everything we do in calculus. So basically, what is a function? It simply is a way of defining a relationship between 2 variables, the so-called independent variable, which is designated x, and a dependent variable, which is designated y. Of course, the whole idea here is that y depends on x, but not necessarily the other way around. Now, we start with the concept of a relation. Okay, this is even more basic than a function. A relation, as you can see there, is simply a set of ordered pairs, which means in each case, we have 2 numbers. One of them, oops, sorry. I'm going to be writing with a tablet, by the way. So not directly on the screen. This computer doesn't allow for that, but I do have this tablet attached to it. And so you have the X's and you have the Y's. Now, if you notice, we also have these symbols called braces. And that simply means this is a set. A set is a collection of objects or numbers or colors or flavors, whatever it happens to be, where the order in which they're listed is not of any real importance. Okay, so this is a set containing three ordered pairs. Now here's a specific set of ordered pairs. And so you can see there's just the three values. And so this is a relation. What we don't know yet is whether or not it's also a function. A function is a special case of a relation. Now, before we do anything, we're going to remind you of two very important ideas. For any relation like this, we have what's called the domain, which is nothing but the set of all the possible x values. Okay, so you can see down here we have the set 1, 2, 3, and all it is three x's. Now, of course, it's starting to come back in your memory, I'm sure of it. As we speak, you're starting to remember, well, what about the y values? What is that called? That set is referred to as the range of the relation. Okay, so here we're gathering up all the y's, and this is what we end up with. So every relation and every function has a range and a domain. Okay, the domain is the x's, the range is the y's. And we'll spend some time identifying the domains and ranges of different functions. Now, what is it that makes a function special? Well, here's the thing about it. What has to happen is that each x is associated with a single value of y. If that's the case, then our relation is also a function. If not, then it is simply a relation. So now let me show you some examples. I think it'll be very clear when you see these examples. We have a special type of graph here. And what you're seeing here is the equivalent of this set of ordered pairs. Okay, so in other words, the one is associated with 5, 2 is associated with 15, 3 is associated with 10. So this graph is just a visual way of looking at this relation. Now, here's the big question. Is this a function? And the answer is yes. Do you know? Because each x is associated with a single value of y. Okay. They don't have to be in any particular order. It doesn't matter that 2 goes with 15 and 3 goes with 10, for example. What matters is that each of the x's is associated with a value of y, just one. So let me show you two cases where we have a relation that is not a function, and let's try to figure out why. Now, here's one, and this is the equivalent of 1, 5, 1, 10, 2, 15, 3, 10. Now, what's wrong here? X is associated with two different y's. So that means it is not a function. That's all it takes. Okay. Now, here's the other way in which a relation might not be a function. Let's look at this case. Now, you notice here, x equals 1 is not associated with any of the y's. It's just sitting there by itself. It is not associated with any y. Therefore, this is not a function. So if there's an x associated with 2 or more y's, or an x associated with no y's, this is not a function. So that's why you can see here, we do have a function. Each x is associated with a single y. But here, no, this is not working because x is associated with x equals 1 is associated with two y's, and here x equals 1 is not associated with any y's. So in both of those cases, we have a relation that is not a function. Now, here's a fun example. Imagine yourself walking into a Dunkin' Donuts and there's a chart showing you the prices of the different sizes of coffee. So the sizes are the x's because the price depends on the size. Notice each size is associated with a unique price. Okay. And therefore, this is a function. It's a very simple function, but it's a function. So, in other words, the small size doesn't have two different prices. Like in this case, imagine if these were sizes and prices, this would be the equivalent of one single size. Like small, for example, be selling for both $5 and $10. And this one would indicate that the size of one, whatever that is, doesn't have a price at all. So you can see those are clearly not functions, but this one is. In fact, we can write it in a very compact way. The price is a function of the size. And that also indicates that size must be the independent variable. And price is the dependent variable. Okay. And this is what the table would actually look like. And you can see just by looking at it that it is a function. Now, here's an interesting one. We have people and we have birthdays. Is this a function? Well, the answer is yes. And here's why. Because even though these two people have the same birthday, that is actually not relevant because all that matters is that each of these individuals has one birthday, and that's it, one. Okay, if John Rivera was listed with two birthdays, it would not be a function. Or if John Rivera was listed with no birthday, it would not be a function. So what matters is that each of these people has a single birthday. And in fact, I don't think we did this example with those graphs. Um, let's see. Let me see if I can come up with an example of this. So we have two people with the same birthday. So this is fine. This is a function. It doesn't matter that nobody has two as their birthday, let's say. Let's say these are people and birthdays. What matters is that each X has a single Y associated with it. Okay. Now, the domain of a function. We know that all the X values that can be substituted into a function are known as the domain. Okay. So it was easier to think about this with the relations. All you're really doing is making up a list of all the x's. But with a function, potentially the domain can be infinite. So basically, the strategy here is the domain contains all, we'll call it D for domain. X such that the function is defined. What do I mean by that? Well, imagine you had something like this. Let's say our function is something simple like y equals x squared, let's say. The domain is all the real numbers, which will write like this. Why is that? Because no matter what value we substitute in for x, we will get a corresponding value of y. But if you had something like this, ooh, now we have a bit of a potential problem. The domain is basically all, let's write it like this. X not equal to 0. Okay, that's a compact way of doing it. You could write it in set notation as, and then what is that supposed to mean? Well, just a quick reminder, when you write, actually, I shouldn't have written it like this. Sorry, hold on. There we go. Just as a quick review, let me just remind you how these symbols work. Say it's something like this. The interval from 0 to 10 written like this means that this does not include, you might recall, like sometimes you see in textbooks, it's written with this whole, I don't know if you've ever seen it done like that, but if you had something like this, if I change the left parenthesis to a bracket, this means including the 0, but not the 10. And that would be drawn like this. At 0, you'd have a solid circle here. This one would be a hole. And then you might have something like this. Including 10, but not 0. And now you have the opposite. And then in this last case, this includes both the 0 and the 10. And then if you drew this on the real number line, these would both be solid. So solid means including that number. A whole hollow circle means not including that number. So 0 to 10, not including either endpoint, would be this one. 0 to 10, including the 0 but not the 10, is here. 0 to 10, including 10 but not 0, is here. And then including both is here. The only exception is infinity or negative infinity. We normally just put a round parenthesis for negative or positive infinity. Okay. So bringing us back here, the domain in this case could be written in set notation as so what this is basically saying, this is the symbol for a union, by the way. We're combining two sets, the set that contains everything from negative infinity up to, but not including the 0, combined with the set containing everything from 0 up to infinity, not including the 0. So in other words, it's a very roundabout way of saying everything but 0. Okay, so you can always express domains in many different ways, but some books prefer to use intervals. Some of them might use something like this. The bottom line is zero is not allowed because that would lead to division by zero. We can't have that. So in other words, here the domain is all real numbers except zero. That in English, whereas over here, anything goes. Okay. There's no real number that could cause problems for x squared. Now with the range, we're looking at the outputs of a function. Now, if you had, for example, here, the way it's written, x and y go on forever. So here the range is all the real numbers from negative, oh, sorry, once again. So the range is all real numbers. Whereas for something like this, again, we'll go back to y equals x squared. If you notice the way this is written, there's no value of x that could lead to a negative value of y. So here the range is everything from 0 up to infinity, but this time we include the 0 because if x is 0, y is 0. So in other words, it's all the non-negative real numbers. Okay. Now, evaluating functions. Often we want to take a function and come up with a specific value for it by plugging a constant value for x. Okay, so let's say, for example, here's a really simple case. If you go to a gas station that charges $3.65 per gallon of gas, the function that represents the cost of the gas that you've bought would be f of x equals 365x. And so if I buy 10 gallons, clearly I'm going to pay $36.50. So what I've done here is evaluated the function at x equals 10. Okay, so once again, the 10 is replacing the x. Now here it's a little bit more complicated, but it's the same idea. This is a quadratic function. It's a parabola. It looks something like this. That is close enough. And I want to know what the value is when x, let's say, equals 7. How do I know? I plug in 7 for each x. Oops. And make that just a little neater. And then you evaluate it. If you notice here, I've replaced all the x's with 7s, and I end up with 35. By the way, I want to mention something here. If you really can't visualize what a function looks like, there's some interesting online tools you can find. One that I use sometimes is called Symbol Lab. There's probably others that are better, but I like this one. It's cheap. It's free actually, unless you buy the professional version. And you can go to it and say, listen, Symbol Lab, I'm not sure what this looks like. Say, all right, what is it? X squared minus 3x plus 7. And you can hit the go button. And one of the options that will offer you is a graph. Now, if you notice, it's giving me the domain, it's giving me the range, it's giving me all kinds of stuff. But right now, all I care about is the graph. And so mine is not perfect, but it's pretty good. It looks like this. And so where x equals 7, wherever that is, I would end up with 35 for y. Okay. Now, sometimes, and we're going to see a lot of this going forward when we introduce new definitions, you can actually evaluate a function by using a constant which is not specified. Here, for example, a, whatever a represents. f of a is 3a plus 7 because I've just replaced the x with an a. We'll definitely need this when we're introducing limits. Okay, so and you'll see why when we get to that point. Solving functions. Now here, what you're doing is you're trying to figure out what value of x is associated with a specific value of y. Usually that value of y is 0. Okay, so here, for example, we have f of x equals x squared minus x minus 12. What values of x correspond to f of x equals 0? So really what you're doing here is this. This is your parabola. And you notice because it's a quadratic equation, there will be 2 points where it crosses the horizontal axis. We'll call these x1 and x2. These are the 2 values which, when plugged into this function, provide us with a 0. And they are said to be the solutions, or sometimes they're called the roots, or sometimes they're called the zeros. Of f of x. Okay. Now, there's different ways we can go about this. You could, for example, use factoring. And let's just quickly review that. You could also use the quadratic formula. Okay, so with factoring, you're looking for 2 binomial terms whose product is equal to this function here. We'll call it x plus m and x plus n. Then we're going to solve for m and n. So what we know here is if you were to multiply these out, by the way, I've noticed that there's different people have learned different ways of multiplying terms together like this. The most general way you can do this. Now, this is what I was taught. That may be different from yours. I've seen people draw box diagrams and things like that. You're multiplying all the terms together. And then you just write them down and you add them up. Another option for something like this is to use FOIL. Remember that first, outer, inner, last? That only works though for binomial expressions. So this is the result of multiplying these 2 terms together. And so for this case, if you notice, that implies that the coefficient here, -1, is equal to m plus n. Coefficient here of -12 is m times n. So we need 2 values such that their product is -12, but their sum is -1. So we can try some possibilities. What I usually do is start with the products. These are pairs of integers that satisfy the second equation. If you notice, every one of these pairs of numbers has a product of -12, but only one of them has a sum of -1, and that would be this one. So that means the m and the m are 3 and -4. M is 3, n is -4. If you multiply them out using this approach or possibly FOIL, you'll see that we've done this correctly. Then, even more importantly, because of this, this statement right here implies that x plus 3 equals 0 and x minus 4 equals 0, which tells me that my 2 solutions are -3 and +4. Those are my solutions. Okay. So now the other approach would have been to use the quadratic formula, which I personally agree. I mean, I think we can all agree that's probably easier. Um, I don't know, maybe that's just me. Let's prove it. Remember, the general form of a quadratic equation is this. And based on these letters, the two solutions to any quadratic equation can be obtained with this formula. So in this case, a is 1, the coefficient of x squared. There's an implied 1 here, by the way. B is -1, and C is -12. Those are the coefficients of those three terms. So I make some substitutions. Be careful with all of those negatives. So we got 1 plus or minus radical 49 over 2. Okay, 1 plus or minus 7 over 2. Which means 1 minus 7 over 2, comma, 1 plus 7 over 2. What do you know? It's the same. So those, again, are the solutions to this quadratic equation. Whether you find it with factoring or whether you find it with the quadratic formula, you'll end up with the same thing. Now you can double check this if you want. By plugging those two numbers in here, you'll see that in both cases, you'll get a 0. Actually, I've done it right here for you. And you can see that evaluating at -3 provides us with a 0, and so does +4. All right, and so that means we must have done this correctly. Now, this is taken from Excel. Excel is a great product, but it doesn't always do the best possible job with graphing equations. So that's why I often end up using Symbol Lab, just because that's what it's meant to do. For example, here, what do we have? X squared minus x minus 12. Let's just switch this. Yeah, there it is. And it'll tell you just by hovering over it, -3, 0 is the intercept on the left, 4, 0 is the one on the right. Of course, the first term here is the x. The 0 is understood because we're looking for points where y is 0. So the second term, the y coordinate, is always 0 in these cases. Now, later on, we'll see that it's awfully important too to be able to find the minimum point of this function, but that will have to wait a little bit longer. The intercept. How do we find the intercept of a function? Well, the intercept means typically, by the way, there can be a vertical and a horizontal intercept. When we hear the words intercept, we normally are thinking in terms of the vertical intercept, meaning where does it cross the y-axis? But there's also a horizontal intercept. That would be right here. So just the word by itself, intercept, usually it implies that we're talking about the vertical intercept. How do we find it? Well, it's very straightforward. You just evaluate it where if you can see on the vertical axis, x is 0. So you just plug in 0. You evaluate the function when x equals 0. Okay, so here, for example, we're replacing all the x's with zeros, and we end up with negative 12. And you can see that that looks about right. It's hard to tell with Excel sometimes. That's the point 0, negative 12. In fact, that should have shown up here. Wait a minute. There it is, 0, negative 12. One-to-one functions. Now, functions can be classified in several different ways. One important idea is this notion of one-to-one functions. With the one-to-one function, what's different is that, yes, of course, each x goes with one y. But with a one-to-one function, it must be the case that this works in both directions, meaning that each y is only associated with a single x. So this is a one-to-one function. Let me show you one that's not. Oh, whoops. All right. So yeah, let's do that again here. This one is one-to-one. Now this one is a function, but it's not one-to-one. That's because y equals 1 is associated with more than one x. Now, let me give you a couple of real-world examples of this. We'll start with the birthday case. The birthday case, let's go back and find that chart with the birthdays. So each person has a birthday. So that means this is a function, but the fact that two people can have the same birthday means that it's not one-to-one. Okay. So it's a birthday. I'm sorry, the birthday is a function, but it's not a one-to-one function. On the other hand, the function that ties together people with their social security numbers is one-to-one. It's coming up next. Here it comes. Here it is. Each person has to have a unique social security number. Okay. So that means that this is not only a function, it's one-to-one. You can't have the same social security number attached to two different people. So therefore, this one is one-to-one. All right, so that's the distinction. Now, why does this matter? Well, you'll see there's certain applications where this can come in handy. Let me just toss one out to you. We can prove, we're not going to do this here, but a one-to-one function is guaranteed to have an inverse. We're going to remind ourselves later on how to find inverses. But it turns out not all functions have inverses. So luckily, we can see that if the function is one-to-one, even if we're having a hard time finding the inverse, we know that it exists. So there are certain ways in which knowing that this is a one-to-one function can potentially be very helpful. Okay. All right. How about this one? Is it one to one? Let's find out. So what we need to do, we can actually put together a chart here. Now you can see if I put together one of these types of special graphs, here are your X's and your Y's are over here. Okay, already you can see it's not one to one. Yeah, you can see 4 is associated with both 2 and -2. And over here, y equals 1 is associated with both 1 and -1. So the answer is no. Okay, it's a function, of course, but it's not one to one. Now here, interestingly enough, there's a graphical device that we can use to help us determine if it is in fact a one-to-one function. And that is called the horizontal line test. So if I were to come back here and try to draw lines to this, well, that didn't work out so well. It's supposed to be a straight line. So if a horizontal line crosses the graph twice, I guess what I should say is more than once, because it could cut through it 3 times. The function is not one to. That's all it takes. Just look at it visually. If the horizontal line cuts through and touches the graph more than once, even once, that means it is not one to one. Uh-huh. Now, on the other hand, oh, what about this case? Well, if you made up a chart, you could try that. Similar to the other one. Let's run through the same ones. -2, -1, 0, 1, and 2. So far, we haven't found any cases where there's more than one y associated with the same x, and that's because they don't exist. This is what y equals x cubed looks like. And you can see the horizontal line test passes because no matter where we put the line, it'll never cross this function more than once. Of course, the reason why this is happening is because the cube of a negative number is negative, whereas the cube of a positive number is positive. That's what's different between x cubed and x squared, where negatives and positives are always going to be positive when they're squared. Okay, now here we have another example. This is just a straight line. And again, no matter where I put my horizontal line, it'll never cross more than once. By the way, what's interesting is that there's also another test called the vertical line test. This is just to find out if the function is, sorry, if the relation is a function in the first place. Okay, the horizontal line test is trying to find if our function is one-to-one. The vertical line test is designed to tell us if this is a function at all. And so if you had something like this, this one fails the vertical line test because you can see, at least here, it crosses this graph twice. So this is not a function. It fails the vertical line test. So there's two tests. These are just, intuitively, so you can see at a glance whether or not you have a function or a relation, a function or a one-to-one function. Okay. Now, what we're going to do next is we're going to run through a brief review of several key functions that we'll need throughout calculus. We're going to start with some basic algebraic types of functions, and then we're going to work up to the more complicated ones. Just a quick review of their properties is what we're looking for. We want to make sure we understand what their graphs look like. We want to understand the domains and the ranges, and any other details that might be important. And so, oh, by the way, I think I forgot to mention this right front. My aim is to have these recordings about an hour or so in length each. I think that is the optimal amount of material to learn at one time. 2 hours gets to be a lot. I mean, there's nothing to stop you from watching two of these in a row, but what I'm going to try to do is keep each one down to about an hour or so. And then that way, you know, each one should represent roughly one important topic. And so I will be producing these throughout the rest of the course. And you can look for them in both Brightspace and YouTube. Now, they're going to be in MP4 format. You should have no trouble watching them. I've never had a problem. If you click them on, it should immediately open up and start playing, no matter where you're looking at it. But if you do have an issue, of course, let me know. And so the next lecture we'll pick up with these basic functions, and then we'll take it from there. And like I said, it'll take a few more sessions before we start the new material, because again, we want to make sure that we're still we have all this information fresh in our memories. And of course, as we go through the new material, I'll review if we need to as well. Okay. So, all right, I hope this first session helped bring a lot of pleasant memories back for you, and you can get a sense of where we're going. But again, this was all review, so there's nothing wrong with review. All review, in my opinion, is good review. But soon enough, we'll be starting the brand new material. Okay, so I guess I'll let it go there, and I'll see you all next time.